I would like to start the problem with example 1. Directions: solve the triangle. Anywhere you see solve the triangle, that means find all the angles and find all the sides. So if I start with the first example, I notice they gave me the side opposite of 30 degrees. I know the hypotenuse is 2 times that all the time. I know the hypotenuse is always 2 times the side opposite of 30. Call it A if you wish. Right? If I want to stick with that A. And that would be hypotenuse, but A is 5, so hypotenuse is 10. And this side is always radical 3 times that. This side is always radical 3 times A, right? That equals that side. So this is going to be 5 radical 3. So that's always how we do this. Of course, we're going to learn other ways of doing this, but for now, this is all we want. And we know what this angle is. If this is 30, that's automatically 60. There it is. I solved all the sides, all the angles. If I look at the next problem, this is 30. So everything is based on the side opposite of 30. This is automatically 60. I got that angle. But I know the hypotenuse. Isn't the hypotenuse 2 times the side A, since everything is based on A? But I know the hypotenuse is 4. So what's A? Actually, I could put that right there. So what does that mean? Well, I could use common sense. The hypotenuse is 4 times this side. What do you multiply this side with to get a 4? Well, obviously, what do you multiply 2 with to get a 4? A 2. Once I know this side, I know this side is radical 3 times that. So this side will always be whatever that side is times radical 3. And anywhere here, I take a sine, cosine, or tangent, secant, cosecant, or cotangent of 30 or 60, I get the same value, no exception. It's not like you do it this way, you get an answer, and you do it a different way, then you get a different answer. And what if they told me that this right here is 60, of course. What if they told me that this is a 5? Then again, I base everything on this side A. I say, wait a minute. If I take this side, which is 5, that is radical 3 times the side A. Doesn't that mean this side A must be 5 over radical 3? And let's see if that makes sense. Whatever this side is, if you multiply it by radical 3, you get this side. Take 5 over radical 3, multiply by radical 3. Doesn't that give you a 5? And isn't the hypotenuse 2 times this? What's 2 times that? Isn't that 10 over radical 3? Of course, you could rationalize, but after getting the sides, if you're given a 30, 60, or 45. It's very important to get this down. And I have 3 more on the 45, taking into account all different combinations you can ever get. Well, the straightforward case is this case. That's 45 degrees. Automatically. If this is 45, this is 45 because that's 90. If they gave me the side opposite of 45 to be 5, I know this is 5 automatically. And the hypotenuse, isn't the hypotenuse always radical 2 times A being the side opposite of 45? So radical 2 times 5, isn't that 5 radical 2? What if they gave me the adjacent? Well, if it's a 45, doesn't really matter. If this is 45, this is automatically 45. Whatever this side is, this side is. And I know this is radical 2 times that. There it is. That simple. If I look at F, I notice that they gave me the hypotenuse. Well, I know this angle is 45. That's... Oh boy, okay. I was hitting other keys, I apologize. But they gave me the hypotenuse. Isn't the hypotenuse radical 2 times A, assuming this is A, and this is A in this case? But I know the hypotenuse is 5. I know it's a bit hard to think in your head. What do you multiply radical 2 with to get a 5? Well, the answer is... What do you multiply radical 2 with to get a 5? 5 over radical 2. If you multiply this by radical 2, doesn't that give you a 5? Again, we are going to figure those out using trigonometry in chapter 5. For now, let's just stick with this. So, any given time, I need to use the sine, cosine, or tangent of 30, 60, or 45. I could draw the two triangles, and I'm going to do that when the time comes. I get to this problem, I say, wait a minute. This is not 30, 60, those are not special triangles. If this is 32, this is 58 degrees. Those must add up to 90 degrees. That's easy. If this is 63, I could figure out what this is, because that's 90, that's 27 degrees. That's easy to do. So according to G, they gave me an angle, and this is the opposite. This is the adjacent. This is the hypotenuse. So, for me to be able to use what's given, I need an angle and the adjacent. Well, I can't figure out the other two sides, but this is what I could do. I could say the cosine of 32 degrees is the adjacent over the hypotenuse. Let's call this M, and let's call this K. Or H for hypotenuse, actually. So if I cross multiply, doesn't that say H, the cosine of 32 degrees, equal 5? And H equals 5 divided by the cosine of 32 degrees? So, I get my calculator out, and I make sure I am in degree mode. You see how it says R right there? You want to go to mode, not that mode. You want to go to mode, and you want to go to degrees, which is 3. Now it says degrees. And I write it as I see it, 5 divided by the cosine of 32 degrees. That would be 5.89589. I'm not going to really be that picky. Let's go for 5.9 is fine. If they specify how many decimals to do, we'll talk about those. For now, 5.9. So I know this is 5.9. It would be unwise for you to use Pythagorean now because we rounded this. If you're going to use Pythagorean and say this squared equal m squared plus 5 squared, then you should take at least 4 or 5 decimal places. What I'm going to do now, I'm going to say, let's go to the given. I was given an angle and the adjacent. I want to find the opposite. Which trig function combines an angle, the opposite, and the adjacent? I know that tangent of 32 degrees equals the opposite over the adjacent. And if I cross multiply, m would equal 5 times the tangent of 32 degrees. And if I plug this in my calculator, I would say it's going to be 5 times the tangent of 32 degrees. And that will be 3.1. So, any combination of sides and angles, you would notice that I have a trig function for. I have one for sine, which is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. If I use the given information on the second problem, I know this is the hypotenuse, right? This is the opposite. Let's call that M. And the adjacent is N. I'm given an angle and the hypotenuse. If I want to find the opposite, then I'm looking for a trig function to combine the hypotenuse, the opposite, and an angle. That's the sine. I know that the sine of 63 degrees will equal the opposite over the hypotenuse. If I cross multiply, M will equal 4 times the sine of 63 degrees. M would be 4 times the sine of 63 degrees. 3.56. And again, it doesn't make sense for me to say, look, now I know this is 5, this is 3.56. Let me use Pythagorean theorem, because that's rounded. If I'm going to do that, then I should really take 3.56402.6 maybe. Instead, I'm going to stick with the given, an angle, the hypotenuse, and I want the adjacent. Cosine of 63 degrees equals the adjacent over the hypotenuse. If I cross multiply, N will equal 4 times the cosine of 63 degrees, and N would be 1.82. So I'd say 2 decimals will be sufficient for what we need. Now, can I go backwards? Find the remaining trigonometric functions. Assume the angle theta is acute. What does that mean? Can you draw the triangle? The triangle is the key. This is deriving trig using geometry. So, if I really look at, and let's say angle theta is right there, just so that I don't have to draw this over and over, let me just can I reach that one? No, I can't anymore. Okay, sorry about that. I forgot how these things work. I'm still learning. So, once it copies, you can move it. Okay, here we go. So assume those are my triangles, right? Of course, you can draw them any way you want. We'll talk about that in 6.1. Well, isn't this the hypotenuse, the opposite over the hypotenuse? Doesn't that make, if this angle theta is right there, doesn't that make the opposite a 5 and the hypotenuse a 7? Do you notice I'm missing a side? If I call this side M, wouldn't you say the hypotenuse squared is 5 squared plus M squared? 49 equals 25 plus M squared. M squared equals, what is that? 49 minus 20, isn't that 24? M will equal, plus or minus, I'm going to take the positive, 4 times 6, 2 radical 3. And find the remainder. Well, the sine of theta is the opposite over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. And the tangent of theta is the opposite over the adjacent. And if you rationalize, 2 times 3 is a 6. And I'm assuming you could find the remainder 3 by taking the reciprocal of each. What if I only gave you tangent? That doesn't matter. If this is the angle, this is the opposite over the adjacent. The opposite is a 4. The adjacent is a 3. 3, 4, that would be a 5, or you could use Pythagorean theorem and say 8 squared equal 4 squared plus 3 squared. 8 squared equals 16 plus 9. H squared equals 25, and h would equal a 5. And the sine of theta would be the opposite over the adjacent. The opposite over hypotenuse, I'm sorry. Cosine of theta would be the adjacent over the hypotenuse, and the tan of theta would be the opposite over the adjacent. And you could find the remainder 3 again. I'm going to list them for one of those, maybe here. I know the cosecant of theta is the reciprocal. Oh boy. And I know the secant of theta is the reciprocal. And the cotan of theta is the reciprocal. And if they gave me the secant, I know that's the hypotenuse over the adjacent. So the hypotenuse is a 5, the adjacent is a 2. That means 25 equals, call this m squared plus 4. M squared equal 21, and m will equal the square root of 21. And there it is. The sine of theta would be the opposite over the hypotenuse. The cosine of theta would be the adjacent over the hypotenuse. And the tangent of theta would be the opposite over the adjacent. The next is example 5. Find the value of x given those triangles. Well, I'm glancing at this, and I can see that there is a triangle right there. Where this is 45 degrees. This is a 4. So if I want x, can't I say x is actually a, b? Can't I say x is a plus b? If this is a, isn't it whatever this side is automatically? And if I take the second triangle, if I'm only looking at this triangle, notice how this works. This side right here is b, and I want to find b. Well, this is the side opposite of 30 degrees. Isn't the hypotenuse automatically 8? And doesn't that make this b, this side, just this side? Doesn't that make this radical 3 times that 4? And of course, I could figure out that this is what? This is whatever this is times radical 2. I could figure out all the sides just by using geometry. The book uses trigonometry. I want to stick with geometry. We're going to use trig when we go to chapter 5. How about this problem? Well, I want to know what this side x is. And how am I going to do that? Well, I know about right triangles. Okay. Can I figure out what this side is? This is what I'm thinking. If I look at this whole triangle, right? That's a 30, 60, 90 triangle. So if I could figure out what this whole side is, right? And let's see how this works. Here I probably have to draw that for you because it's going to be too much to see on one. So one of these triangles look like this. And that is the 25, 30. And one of these triangles look like this. And that one is the 60, 25, ignoring this line. Right? So one of them is pretty much right there. And the other is the whole thing. Well, the whole thing has an issue. I know this is the x that I want, but I don't know what that is. Call this a, that's this a right here. Well, let's see. If I know the side opposite of 30 degrees, isn't that double? That's this side. And isn't this radical 3 times that? So this is 25 radical 3, or this a right here is 25 radical 3. Now let's look at this whole triangle. Isn't this angle 30? Isn't it whatever this is? The side opposite of 60. The side opposite of 60 is radical 3 times whatever this is. Can you solve for x? And what's x? 25 over radical 3 minus 25 radical 3. It seems I messed up somehow. Maybe not. Yeah. I'm getting x to be negative. There's no way that could happen. And let me just see why. Yep. 25 divided by radical 3 minus 25 radical 3. And length cannot be negative. I must have messed up somewhere when I set up the problem, not necessarily anywhere else. Let me check really fast. Hold on. I got it. That's the problem. If I'm standing right here in front of this, that angle has to be bigger. If this is looking up 60 degrees, when I go further, I have to look down to see the same. That would be 30 degrees. So those just switched places. We'll get to that in a minute, actually. And we're going to say we're going to talk about that tomorrow. We're going to talk about that now. So let's change those slightly. Not much. So I don't know if you saw it. We could talk about it tomorrow during our class discussion. So that is, if I'm looking up 60 degrees, if I move further, I can't look up higher. I'm looking less. This angle is definitely less than that. So if I look at the 60, and I'm calling this 25. So this is the problem actually right there. This is the 30. So the trouble is here. If I know this is 60, this is 30. Isn't this side right here? So basically I'm saying 25 must be radical 3 times whatever this is. So doesn't that mean a is 25 over radical 3? This is 25 over radical 3. So this here is 25 over radical 3. This is x. This is 25 over radical 3. If this is 30 and this is 25, doesn't that mean... I thought I got it. There. Doesn't that mean this right here is radical 3 times 25? Which means x is 25 radical 3 minus 25 over radical 3. That's much better. If you have problems like that in the homework, we'll talk about it when you ask about those. How about this problem? An observer measures that the angle of elevation. Guys, angle of elevation is when you're looking straight and you look up. That's elevation. From looking straight, if you look down, that's angle of depression. So, an observer measures the angle of elevation to the top of a tree. Let's say the tree is right there. Some person standing right there, the observer, and notice that the angle of elevation, that is from looking straight, they look up 16 degrees to the top of the tree. Assume this is the tree. From a point 200 feet apart, so he's really, or she is 200 feet away. What is the height of this tree? Well, what do you know? I have a trig function. I'm looking for the opposite and I'm given the adjacent. Which trig function combines an angle, the opposite, and the adjacent? Tan of 16 degrees is the opposite over the adjacent. And if you cross multiply, h would be 200, the tangent of 16 degrees. Since that's not a 30, 60, or 45, I would use my magic tool. I am in degrees, 200 tangent of 16 degrees. And I'll get 57.35. 57.35 feet. That would answer that question. Let's get to the next problem. An air balloon is rising from the ground from a point 200 feet from a building. Let's say the building's right there. And this balloon is 200 feet away from the building. Right? It's going up. An observer measures that the angle of elevation to the top, so at a given point, the angle of elevation that's looking to the top, this measures 27 degrees. And the angle of depression to the bottom of the building, that right there is 19 degrees. How tall is the building? Well, let's see how this works. If this is 200 feet, isn't this 200 feet? That's a 90 degree. I'm looking at this triangle, and I'm thinking I can find this side A. I'm looking at this triangle, and I'm thinking I can find this side B. And wouldn't you say the height of the building is A plus B? So if I look at the yellow triangle, the opposite and the adjacent is 200. Wouldn't that be tangent of 27 degrees equals the opposite over the adjacent? If I cross multiply, isn't a 200 the tangent of 27 degrees? If I look at this triangle, there's an angle, the opposite is B, and the adjacent is 200. Wouldn't you say tangent of 19 degrees equals the opposite over the adjacent? If you cross multiply, B would be 200 the tangent of 19 degrees. And, of course, the height of the building, that would be what? It'll be this plus this. I would throw this in my calculator and do it one shot. No need to round quantity few times. So what I'm going to do, I'm going to get my calculator out and do the whole thing one shot. 200 the tangent of 27 degrees plus 200 the tangent of 19 degrees. And I'm getting 170.77. H would be 170.77 what? Feet. Alright. We're going to stop right here. That would be the end of this section.